Hey there, barcoders! Welcome back to the IDAutomation channel. Today, we're diving into the freshly updated Java barcode component from IDAutomation, specifically the QR Code edition. Our mission? Building a RESTful API with Spring Boot that generates dynamic QR code labels in a Word document. I'll guide you through each step. While this task might be a bit advanced, I'm confident you'll be able to follow along and learn something new. A link for the written tutorial will be in the description below. To get started, we'll need the IDAutomation Java barcode component, QR Code Edition, IntelliJ, Maven, Postman, Microsoft Word, and a few dependencies that we'll add along the way. Trust me, by the end of this, you'll be unlocking yet another incredible capability of our software. Let's dive in. It's a good one. Let's head over to Spring Initializer to set up our project. I'm using Maven with Java and selecting Spring Boot 3.4.0. For the metadata, I'll add my group name and a description. Feel free to make it your own. I'm going with Java 17 for this demo, but Java 21 works too. Finally, we just need two key dependencies, Spring Web for building our API and Spring Boot DevTools to keep development smooth. Great! With our dependencies set, let's generate the zip file. Once it downloads, I'll extract it and open the folder in my IDE. I chose IntelliJ for this project, but use whatever works for you. Next, we'll load the Maven script to pull in all our dependencies and configurations. Once that's done, we can check out the source folder to see what's been set up so far. Before jumping in, it's smart to run the project once to ensure everything's working. It'll default to port 8080, so if something else is using that, you may need to tweak your settings. The project is up and running, and the console output looks great. Everything's working as expected. We can stop the application and shift focus to adding some additional dependencies. Head over to our pom.xml file. This is Maven's hub for managing dependencies in our project. Here, I'll add references that let us interact with and build Word documents directly from our application. Don't worry, these will all be listed in the tutorial link below. Next, let's add our IDAutomation jar file. Click the settings icon in IntelliJ, go to Project Structure, and under Libraries, hit Add. Browse to your jar file. Its location depends on where you extracted your IDAutomation Java barcode component. Once added, you'll see the IDEA QR code jar in the external libraries, and you can even explore its package structure. We'll add it through Maven later, but for now, this gets us ready to use it in our project. Back in our demo application class, below the main method, which is our entry point, we're going to create a controller, the real brain of the application. Let's break down some key annotations we'll use here. First, @REST_controller. This allows the class to handle HTTP requests and send responses. Next, @RequestMapping. This sets the base URL for all the endpoints in this class, so every endpoint will start with /API/labels. Our class is called QR Code Label Controller. No ambiguity there. I'll be importing the necessary classes as we go. The post endpoint will be /generate. With that post mapping, we're handling the HTTP post requests for /API/labels/generate. We set produces to a media type, one which tells the client the response will be a binary file, like a downloadable Word document. As you watch me import the necessary classes, don't forget, they'll all be included in full down below for reference. We're using response entity for our method, which is super handy because it lets us customize everything: HTTP status codes, headers, and the response body. Here, the body will be a stream of the Word document we generate, all wrapped in input stream resource for efficient delivery. Our parameter is a list of product IDs. This tells Spring to expect a JSON array of product IDs, specifically in the request body, which it conveniently maps into a list for us. So, you send over your product IDs, and this method hands you back a Word document filled with dynamic QR code labels. And of course, the whole thing is wrapped in a try-catch block. Error handling might not be glamorous, but it's critical, so don't skip over it. Now it's time to create our Word document using Apache POI. This library is perfect for generating and editing Office files in Java. By initializing a new Word document with XWPF document, we've got a blank canvas ready to fill with content. We'll also wrap our table generation logic in another try-catch block. This ensures we've got some robust error handling in place, making our application more reliable and easier to debug if something goes wrong. Creating a table for our labels is the next step. Tables in Word documents are structured with rows and columns, which makes them perfect for neatly organizing our labels. But hold on, our POI dependency is showing red. Don't worry, I left this in on purpose because you might run into the same issue. Our import statement isn't working as expected, so head back to the pom.xml file and we'll fix this. Click the little M in the right corner of IntelliJ. This reloads the Maven changes we added earlier. Once that's done, head back to our demo application and voila! POI is no longer red, meaning it loaded correctly. Problem solved. Back to our table. The remove row at 0 line clears out the default row that's automatically created when we initialize a table. This gives us a clean slate to dynamically build rows as needed. Next, we define how many labels will fit in each row by creating a variable called columns per row, and we'll set it to 2. Then, we'll introduce current column, which helps us track which column we're in as we loop through the product IDs. We'll also declare a row variable to represent the current table row. We'll start it as null. It's time for a good old-fashioned for loop. This will iterate through each product ID in our list, but with a twist, we'll add a condition to skip any IDs that are null or blank. Clean, efficient, and error-free. For each product ID, we'll generate a QR code. To start, we define the file name for the QR image by combining the product ID with -qr.jpg. Next, we'll instantiate a new QR code object to encode our product ID. But wait, it seems reloading our Maven dependencies has caused the QR code jar file to vanish from our imports. Even manually adding the import statements isn't working. No worries, though. If you check your external libraries on the left, you'll notice the QR code jar file is missing. Let's fix that. Head back to the project structure, reload the jar file into our libraries, and don't forget to remove the old reference while you're at it. Problem solved, and we're back in action. The IDEA QR code jar now reappears in our external libraries, and we can get back to our QR code generation with no more errors surrounding our import statements or new QR code object. Let's set the encoded data to our product ID. This step ensures the QR code is customized with the correct data for our barcode generation. Next, we call on the barcode encoder class to create and save the QR code as a JPEG file. We pass in the QR code object, the image type, and the predefined file name. It's time to populate our table. First, we check if current column is 0. If it is, we create a new row in the table. Then, we check if the current cell exists. If not, we create a new one, ensuring each label has its own dedicated cell in the table. Here's where the actual label takes shape. First, we create a paragraph in the cell. We add text like label 4, product 1, followed by a line break. Now, it's time to embed the QR code image into the Word document, which is the heart of adding visuals to our table. We start with a try block to handle any exceptions that might pop up. Inside it, we use file input stream to read the QR code image file we generated earlier. Next, we create a new XWPF run object within the paragraph of the cell. This tool lets us add both text and images to the paragraph, and the image run will hold our QR code image. We then use the add picture method to embed the image into the document. The image stream reads the image data, while XWPF document tells the library that it's a JPEG. We also include the file name to keep the image's metadata consistent. Finally, we use units.tmu to set both the width and height of the image in EMU English metric units, resizing the image to 70 units each. Thanks to the try with resources syntax, the file stream will automatically close after we're done, avoiding any resource leaks. After filling a cell, we move to the next column. If we've reached the maximum number of columns, we reset to column 0 and start a new row. Once we have all the labels to the Word document, the next step is to finalize the document and prepare it for download. To do this, we save the document into memory using a byte array output stream, allowing us to capture the entire content of the document as a series of bytes. Before moving on, we take a moment to clean up. The QR code image files we generated earlier are no longer needed. So, we delete these temporary files. It's a small but important step to ensure we're not leaving behind clutter on the server. Now, we're ready to send the document. First, the byte array from the byte array output stream is transformed into a byte array input stream. This converts the document's raw data into a stream format that can be used for transmission. Next, we wrap this input stream in an input stream resource, which is Spring's way of signaling that the body of the HTTP response will be streamed directly to the client. Finally, we construct the response itself using response entity. Setting the status to 200 OK indicates that the request was successful. A header is added to mark the response as a file download, and we specify the file name so the user knows exactly what they're receiving. The response content type is set to application/octet stream, a standard for binary files, ensuring it's compatible with most systems. The input stream resource, which contains the Word file, is attached as the body of the response. When all these steps come together, the result is seamless. The finally block ensures that the XWPF document is always closed, even if an error occurs during the document creation or response process. By calling document.close, we release resources and prevent potential memory leaks. Wrapping this in a try-catch handles any I/O exception that might occur during cleanup, ensuring the application doesn't crash. Let's head back to the top and debug our annotations. Last we left off, it still was displaying an error, though you may have already spotted the fix. I accidentally added a semicolon onto the end of our @request mapping. Once the semicolon is removed, we have no more errors. Now we can see our magic, or more specifically, carefully crafted code in action. We run the project and everything compiles and loads without a hitch. Open up Postman so we can test our API. We'll load in the URL we've crafted. Localhost 8080 with the properly formatted API/labels/generate. Navigate to the Headers tab, and I've already added the content type as application/JSON. It's as easy as entering in a new key and value. The next step in our testing is to add in the raw JSON data for our product IDs. I've preloaded this data, but just ensure you're utilizing the raw data and proper JSON formatting. I included 6 unique product numbers. Be sure to switch from a GET request to a POST request, and now we can send our request. We've gotten our response, so go ahead on the right side above the response and select Save Response. This will save our QR code label document. Upon saving, go ahead and open the Word document to examine our labels. And voila! 6 unique QR codes and labels dynamically created from our API call. And that's our code. But before we go, I do want to briefly touch on how to incorporate the IDEA QR Code Jar as a dependency in Maven. Go ahead and stop the project and open up the terminal. We're going to be using a command to install the jar into the Maven repository. Then we'll reference it in our POM file and run the application one more time for good measure. We've installed the jar to our Maven repository. Now in our POM file will load in our IDAutomation dependency. We'll paste in our dependency information. Ensure it's placed within the dependencies tag. Don't forget to reload Maven. Now we won't need to reference the jar via the external libraries. Awesome! Let's real quick run our test one more time to ensure functionality. With the project running, open Postman and change one of the product numbers. Hit send and we'll download the new response. Open it up in Word and we see everything ran as intended. Let's recap. The user makes a request to the API and receives a downloadable Word document filled with their custom QR labeled data. This process not only automates the generation of the document, but also ensures everything is cleaned up and ready for the next request. This is just scratching the surface of what you can build with our software. Thanks for watching, and as always, we are your source for quality symbology.